This structure system mainly consists of cast-in-place columns with column caps, cast using large steel molds, pre-tension pre-stressed composite beams, and precast multi-ribbed slabs. It is suitable for standardized multi-story reinforced concrete projects with heavy loads, high ceiling, and long span. Widely implemented in multi-story logistics warehouses and large-span industrial buildings. It achieves the optimal combination of precast components and cast-in-place methods. The pre-tension pre-stressed composite beams can be prefabricated on-site or at a nearby factory. On-site roads or parking lot concrete pavements can be used as the pre-stressing bed, should the beams and slabs be precast on-site. While the beams are being prefabricated, columns are erected simultaneously on-site once the beams are ready. They are transported directly to be installed using mobile or crawler cranes. The multi-ribbed slabs are then installed, and the floor rebar binded subsequently. Finally, the concrete for the beam column joints, the stacked layer of the beams and the slab is poured all together. This system has been implemented in over 300 projects of some well-known enterprises, including VX, GLP, Warburg and Pincus, Logos, Vialog, totaling more than 30 million square meters of space, across all major cities in the country. The structural design of this structure system follows the codes and standards in China. Compared to traditional cast-in-place structures, it has the following advantages. Cost reduction. This system eliminates the need for most formworks and scaffolds during construction, significantly reducing the cost of such measures. Columns are cast in place using large steel mold without the need for operating scaffolds. Beams and slabs are also prefabricated using steel molds, which are calibrated for reuse. The precast beams incorporates high-strength steel strands. A material has 4 times the strength that of regular steel rebar. Beams use high-grade concrete. Both measures significantly reduce the height of each beam, at the same time reducing the steel and concrete usage. For projects with heavy loads, long spans, and large covered space, the cost of construction can be significantly reduced. Larger the project, more significant the cost savings. Compared to traditional cast-in-place structures, cost can be reduced by up to $40 per square meter. Shortened construction time. The framework columns are erected, at the same time the prefabricated components are being produced. Once the columns cures, the prefabricated beams and slabs installation will begin, forming a flowing sequence that is highly efficient. Installation of upper-level beams and lower-level brickwork, electrical work, and equipment installation can proceed simultaneously, as one would see from a steel structure construction site. In all, such construction method will at least save 20 days of time per floor level compared to the traditional method with formworks and scaffolds. Improved concrete surface quality. Beams and columns are cast using large steel molds, achieving a fair-faced concrete effect with refined details. A significant upgrade compared with rough quality of traditional cast-in-place components. Reduced manpower. The streamlined prefabrication and construction process significantly improves the efficiency of workers through repetitive tasks, and requires less management attention. With high degree of industrialization, the number of workers on site can be reduced by more than 60%, making the site safer, cleaner and civilized.